Number 2, the position, which is measured in meters, of a particle is given by x of t equals te to the minus 2t. Position is my first function. And then if I take the derivative of position, what do I get?
The velocity.
Perfect. To get the velocity, I want to find the derivative of x of t, which is equal, we'll call it v of t. What do you notice about x of t?
They're being multiplied.
Right, it's two functions multiplied together. I need f and I need g. I know that the derivative of that is going to equal my velocity, which is f prime g plus g prime f. And so now I just plug in my values. F prime is 1. G is e to the minus 2t. And then plus g prime. G prime is minus 2e to the minus 2t times f, which is t. Again, I have two terms. I can factor e to the minus 2t out of both terms. I would have this times the first term, which would be 1. And then I have a plus minus, so I'm just going to make it minus. I have 2. I have my t. And I'm factoring out the e to the minus 2t. I'm done. You could leave it in this place, but get used to doing this. How do I find the acceleration?
You take the derivative of that, the second derivative.
The second derivative of the position, which is equal to the first derivative of the velocity, which is equal to the acceleration. Now, we're gonna do what? What do I have for v of t? Let me write v of t here. What do I have for v of t?
It's a multiplication again.
It's multiplication again. So I have to use the product rule. I have f and I have g. What can I make f?
Would it be e to the negative 2t power?
And what would g be?
Negative 2t.
1 minus 2t. This is f. And this is g. Because what we have is f times g. So what's the derivative of f?
Negative 2e to the negative 2t power.
Perfect. And what's the derivative of g?
Negative 2.
Perfect. The derivative of a constant is 0. So the derivative of 1 is 0 minus 2t. So, and the derivative of minus 2t would be minus 2 because t becomes 1. This equals f prime g plus g prime f. I have f prime is negative 2e to the minus 2t times g, which is 1 minus 2t, f prime g, plus g prime is negative 2 times f, e to the minus 2t. I can actually just factor minus 2 e to the minus 2t out of both terms. And if I factor it out of the first term, I get 1 minus 2t. And if I factor it out of the second term, I get 1. So this becomes minus 2 e to the minus 2t times 2 minus 2t. I can now factor out a 2. I have minus 4 e to the minus 2t times 1 minus t, because I factored a 2 out of here and multiplied it to the front. Find the critical points. This is very important. Critical points where the first derivative equals 0 or is undefined. Find the critical points, the times t at which the velocity is 0. I have an equation for the velocity. Velocity equals e to the minus 2t times 1 minus 2t from right here. And I want to know when that equals 0. There, I've just made my point, why I want to have things factored. And once I know this, remember what we said, a constant to a variable can never really equal 0. It can get very close. The bigger t is here, the smaller e to the minus 2t gets. This is really the same as 1 over e to the 2t, right? Just this part. Now, the bigger the denominator gets, the smaller the fraction gets. The only way to get 0 when I have a fraction is if the numerator is 0. Because 0 divided by anything is 0. We don't have to worry about that. That can never equal 0. E to the minus 2t equals 0, or 1 minus 2t equals 0. This can never happen. Therefore, I get my critical point is t equals 1/2. Find the critical points. This is the critical point. So we have one critical point. When you have a graph, let's just say I have a polynomial. The derivative equaling 0 means the slope of the line tangent to a point is equal to 0. And that always happens at my maximums and minimums. That's why we find critical points. And then we figure out, is that critical point a maximum or a minimum? And it could be neither. For right now, we're just going to say it's probably a maximum or a minimum. And we only have to worry about when t equals 1/2. Now, the second part of this says, use the second derivative test. Well, the nice thing is we already know what the second derivative is. X double prime of t, which was a of t, is equal to minus 4e to the minus 2t times 1 minus t. What we want to do with this is we want to plug in 1/2, because that's my critical point. I use my second derivative and I plug in t equals 1/2. And then what the second derivative test says is that if, we'll say in this case a of t, but if the second derivative, so we'll call this a of t, but it's any second derivative, it's not always acceleration. If it is greater than 0, think of it like this. When I have a parabola with positive coefficient, it opens up. Notice I have a minimum. When the second derivative is greater than 0 or positive, I have a minimum. And if the second derivative is less than 0, well, I have an upside down parabola. When it's negative, I have a maximum. First thing I want to do is I'm going to plug in 1/2, because that's the point that I'm really interested in, is Is that a maximum or a minimum? I say minus 4 e to the minus 2 times 1/2 is 1 to the minus 1 times 1 minus 1/2, which is 1/2. But, and I don't care what the number is. That's a positive number. Here, I have a positive. The e to the minus 1 is
Oh, it
positive.
will be positive, yes.
Yes, but the negative 4 is negative. So correct. The whole thing together, if I multiply that all out, I would get a negative value. That means I found a maximum. Let's see what it says. Use a second derivative test to classify each as corresponding to a relative maximum or a relative minimum. We know that we have our point. So to answer the second part of this question, I would say I have a relative maximum because I think of a parabola with a negative coefficient as opening down. So I know it's a maximum. My ordered pair would be 1/2. And then I have to go back to the original and plug 1/2 in here. When I plug in 1/2, the second derivative tells us if it's a maximum or minimum, but it's all having to do with the original function. That's what I mean. We have minus 2 times 1/2. We get this equals e to the minus 1 over, so it's 1 over 2e actually, because this becomes e to the minus 1, right, times 1/2. So e to the minus 1 is 1 over e, so 1 over 2e. So my ordered pair would be 1/2, comma, what did I say, 1 over 2e. And now let's graph it. My function is y equals t e to the negative 2t. Let's look at it like this first. You can see that basically the shape of it is doing this, right? And so we can see that that's a maximum. And if we zoom in, we can see it even better. And we did find that it was a maximum.